Good evening, and thank you all for joining us today. My name is Rashmita, and I'm the event planner for Microsoft Reactor Bengaluru, India. The session will run over the next 60 minutes, including Q&A. The session is being recorded and will be uploaded to our Reactor YouTube channel. I will share the link to our YouTube channel in the chat section soon. Before we begin, please take a moment to read our code of conduct. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Also, please keep your mics muted during the session. I would now like to welcome Jigar, our speaker for today's session. Jigar is a partner and senior solutions architect with TechScalable and has 16 plus years of experience. He has trained more than 25,000 plus IT professionals across the globe. He is also a Microsoft certified trainer. But for now, I will hand over to Jigar to begin the session. Over to you, Jigar.
Yeah, hi Rashmita. Thanks for the introduction. Hello everyone. I hope you all are doing well in this particular pandemic situation and keeping your good health. Uh, so today's agenda is to talk about. So let me have a little bit flashback. We had last session on Azure Synapse Analytics. We understood couple of area that what is the offering of Azure Synapse and how we can like leverage that particular solution services basically in terms of working on variety of workload to be analyze on top of it. Now, today, with the extension of that, we will be talking about how we can enhance the performance, what kind of approach we can go for, and how the activity we can do so that we also understand like what are the distribution methods offered by Azure Synapse and like how we can improvise our overall performance activity throughout the life cycle. So that is what we are planning to cover up in today's agenda. So let me share my screen. Let's get started. Meanwhile, I'll stop sharing my video just to focus on our presentation so that we will be continue learning, and we'll have a small demo as well where we're going to take a look at it. That if we wanted to take the advantage of similar kind of activity with Synapse dedicated pool, and if we need to provision and configure things, what will be the best way to go for it? Yeah. Uh, just a quick announcement regarding the Q&A. If in case if you guys have any queries or questions, please feel free to post in your chat window. We will take those questions in logical break, and then we will talk about it like how we can move forward in that case. Yeah. So yeah, I think looking for great session, and let's get started. So I'm just sharing my screen and probably stop sharing my video. Okay, so I hope you guys can see my screen and it's visible to everybody.
Yes.
Okay, thank you so much. Okay, so what is the overall today's agenda, what we are planning to cover up? So the learning objective is this for this particular session is to, again, we will have a small recap of what are the core component of Azure Synapse Analytics when we are planning to query some particular data. Majority time, lot of enterprises coming up, or maybe let's say for example, being a data engineer, when you're running certain queries and all on top of the Azure Synapse, then you might face some issues in terms of performance related or query related, or maybe when you're running certain kind of activities, then maybe you may have some low concurrency. Because of that also you may face some query low latency and performance issues. So we will understand that. We'll also talk about distribution design methodology, which is something available with Azure Synapse when we are planning to go ahead and distribute our data in the form of like, let's say, table and all, or we can call it out as an in general, you can say a kind of sharding mechanism, which is something made available with Synapse platform. So how we can leverage that, what kind of features we can associate, and we will understand those particular methods also in a step-by-step way. And we'll have a small demo where I have created a dedicated SQL pool, and probably we'll take a look at it, what all the configurations and design considerations we can think through, what kind of like approach we can take care of it, which may impacts in your overall activity or your overall performance and all, right? So that's something what we are planning to cover up. Now, in general, when we are planning with our Azure Synapse Analytics, then definitely there are a couple of features made available in analytics, as in what do you say, the data warehousing services. So just a second, let me have some water. Just a minute. So what we can do is that we're gonna have a particular options in terms of kind of what kind of warehouse options we are looking at it, what kind of components we need to figure it out. So this is something a kind of design architecture where we can say that if we get a particular dedicated SQL pool, then the activity what we are expecting over here is that we just need to figure it out that whenever you provision the resources, you may get serverless or you will get a dedicated pool. Now, when you're planning to create Azure Synapse Analytics infrastructure, by default, you will get serverless pool along with it, right? As soon as you provision your particular Azure Synapse Analytics, then by default, you will get a serverless pool. But if you are intent to go ahead with dedicated pool, because dedicated pool comes up with standard costing, they have default pricing tier, and then the assumption is that it will run for a long time, and we wanted those particular query to be run on top of it. So we can go ahead and simply provision this particular instance. There are two way: either we can do it via Synapse Analytics options, or there is still one more way where we can provision from portal directly, saying that dedicated SQL pool, which is also known as, formerly known as an data warehouse kind of service and all. So multiple way to provision the services. In my previous session, I talked about like what are the best way to get three elements, either dedicated pool, see serverless SQL, or probably we can get the access of this Apache Spark pool and also. These are the three integration options available in ASA Studio, Azure Synapse Analytics Studio, where we can simply go ahead and provision these particular services. And of course, along with that, you have some particular additional options in terms of working with those elements that you can have integrations, you can have pipeline and flows to be created, you can play around with some security models and lot many activities, and all of them will be possible with your particular Synapse Studio. So in general, the overall structure basically made available with Synapse Studio, whereas you can play around with all these particular activity. So today's session is not all about like what we are going to like how we can provision and what we're gonna do it. That is something I have covered in my previous session. But today we're gonna take a look at it, the uh, performance issues that when we are planning to work, when we are working with our Azure Synapse Analytics and all that, right? So when you have concept where you can say that Azure Synapse Analytics offers MPP engine. So that engine basically massively parallel processing. So that's the default engine offer underneath with Azure Synapse Analytics, right? Which allows you to load and query your large set of data in that background. Now, one of the biggest issue we start facing is the performance issue, right? That whenever we are trying to perform certain queries or try to execute some particular data on top of it, and we wanted to make sure that we get some particular accurate result in time, and you know that sometimes like, okay, this query shouldn't take a long time, this query should run within so and so minute or so and so second, and we should get some particular result out of it, depend on the data size and all. So here, what is the objective? We need to understand that when we are uh, enabling our platform, so there are three core elements I can see, right? I mean, there are times where you can see the performance are not up to the mark. It may be possible because of the variety of reasons. Now, here I can say that couple of three core reasons I can identify. Probably you can say query performance, maybe the load performance, which may whatever the date. So, for example, if you say that load performance, so it starts with with my data, right? Whenever you are trying to dump your particular data into the system, then initially uh, you need to figure it out that let's assume that your data is getting loaded through your Synapse pipeline, right? Or you may get user reporting that data in reports are out of date or something like that. So usually the informations which are getting triggered into the system because of the size, because of the probably the telemetry of that particular data may out of date or something like that, and because of that you may face certain kind of data load issues. The second one is like probably the low concurrency. Now this is something one of the core component. This is something what we can think through is that when you receive reports from your users that you are users or probably the engineers who are working on your particular environment and all, and they say that hey, we execute this, the informations what we are trying to trigger, or maybe the scalability is not there, or probably the sign up studio like not responding the way we are expecting with the queries and all. So it may be possible that whatever the instance you have configured, the data warehouse unit, right? It was earlier, it was known as DWU. So DWU was kind of, you can say, it was a default data warehouse unit, which was known for scalability. That it starts with 100 to 3000, like almost in between. You can pick and choose when you are planning to provision your SQL pool instance, because that is what the initial configuration you need to provide to your data warehouse unit, right? Your dedicated SQL pool. So when you provision that, it will ask you that what is the performance metric you are expecting. Now, here a little bit off the topic from the scalability point of view. A lot of people says that, okay, I mean, once we provision the resources in cloud, then we are done. I mean, we don't have to go back and see that how the performance is, or if we go ahead and provision with recommended, what do you say, configuration, then we are done. We don't have to look back. But from cloud point of view, since the experience what I have so far, I always say that you should always follow this mantra that a lot of people start their journey with migration, probably modernization, innovations, and all that particular those terminology people use it. So I always follow the this particular pattern that migrate, monitor, and optimize. Right. This is something basically, or after migration, I can say monitor, optimize, monitor, optimize. This is the common rule or common like. You can say the approach which you can take it from the cloud point of view, because on premise is that's a different story. Usually you have one server on premise and you say that unless and until we're not going to buy or enhance the capacity of this instance, we will get the same configuration, so no need to worry about it. But when it comes to cloud, we always have to keep checking whether the consistent the size of that resource, the consistency is expected with the same configuration or not, right? So that's why I call it out at sin monitoring and optimization. So monitoring is like constant monitoring of your transactions, your queries, your performance, the concurrency, what is expected for the size of the data, what you are trying to execute, and the response time of that particular queries what you are trying to run on top of that, right? So you do you have enough memory, do you have enough concurrency slots available, and how that particular response are working. Now there are multiple way to enhance this particular the activities what the common issues what we are talking about, right? So usually it begins with your design as well. So generally what we have when we are planning to create our particular query structures and all, right? So we have normally uh, your data platform looks like this. When you have your Synapse SQL architecture components, then you have couple of elements by default in place. So here you can say that the data might be ingested into the system. You may have your control node, you may have your DMS. So DMS again, it will data movement system that will help you to move your data amongst each of the compute node, and it will help you in terms of processing your data. And by default, behind the scene you have your Azure storage in place, which will help you to capture your particular, dump your particular process data, and later on you can aggregate them and you can get some particular fine-tuned result out of it. Now this is the standard, you can say, execution of your particular Synapse Analytics architecture, your particular SQL pool, which will help you to play around with your particular data processing and all. Now in this, today we're gonna take a look at it. We will be discussing couple of distribution design methodology, right? We're gonna take a look at it. What all the patterns available, what kind of distribution possible with Azure Synapse, and we will work on this particular. We will understand a little bit in detail like how that works and what could be the benefits we can get it out of it, right? So before moving to this, a simple question to all of you, since you guys are having a particular Azure Synapse session attending, so just a quick query or question for all of you as well. What is your understanding? What will be the default method or default, in a simple language, I can say distribute table distribution design or sharding method will be used in Azure Synapse? Maybe you can respond in a chat if you have any idea. What is your understanding towards which is the default distribution design method used in SQL Synapse, or you can say dedicated pool? What we have, what will be the default distribution design method will be used in our Synapse SQL dedicated pool, what we are up and running with it? Anybody has any idea, or if you have heard about, or if you know a little bit, because our topic is completely depend on that. Okay, I see Bhaskar says hash. Okay,
Is it round robin?
okay. So who said round robin? Sorry, I didn't get your name.
Yeah, that's Manu.
Manu. Okay, yeah, you are absolutely right. So round robin is the default mechanism which works with your particular SQL signups, and you can have your particular distribution mechanism applied to that. So this is something what we are planning to discuss today, and we will be understanding that what kind of like opportunity we can have, how those particular distribution mechanism will be applicable to your Synapse Analytics, and what kind of like I mean, what kind of options we will get it during this particular activity and all. So here three elements to it. We will understand them and we'll step by step go ahead and talk about these particular elements. So three of them. Uh, Basically we can have the option of implementing a particular option of hash distribution, right? We will deep dive into all of three. We can have round robin. So round robin is something I can say it's the default one. As soon as you provisioning your particular dedicated SQL pool, and if you do not specify anything, then default one will be your round robin. So depend on your rows and all that, it will distribute to the compute nodes, and then it will process that particular data the way effectively it is expected. And then last but not least, we can have a replicated tables and all. So these are the three core mechanisms what we can think through. So let's understand how these three particular element works and what kind of options available. So here, first thing in place, we'll be talking about, let's say, let me go ahead and say this will be hash So we will first of all talk about this part, and we will go through understanding how the hash works and what kind of options are available. Now, usually when you are talking about the hash mechanism, hash distribution, so this is, let me have some particular graphics first thing in place. So you can consider that, you can assume you may have your particular table, right? So your table may have your rows and effective columns in place. We can consider you may implement your hash function in between, right? And behind the scene, whatever the compute node what we have, because the compute node is something what we can say in our entire oops, in our entire particular design, we just need to plan it out that uh, whatever the elements we are going ahead, whatever the like compute nodes we are going to put it in that particular configuration, there will be like multiple nodes will be configured, right? So I am assuming that we do have our compute nodes in place. Now each compute node, okay, so here you may have your particular table in place, because each of the compute nodes are going to process your particular informations, and whatever the data you have given is something will be distributed. So your table distribution may impact to these particular tables with the compute node what we have. Now behind the scene, I mean, if I want to consider that hash distribution, whenever you like the data stored into the compute nodes from the table, there is an element called hash function. So this hash function is going to take over the responsibility to decide which row should be stored in which node, right? So that is something basically made the decision by this particular hash function. So that will be my mechanism, that each table row belongs to one particular distribution, and as we discussed that if we do not assign, then it will by default take round robin. But if right now we are talking about hash, so hash function basically decides that uh, which particular row should be stored in which particular node, and after the decision made, I mean based on that particular uh, defined pattern, it will store all your table rows into that respective compute node. Each of the compute node what we have is something stored with that particular element. So they will get that respective table into specific distribution whatever we have associated with it. And hash distribution is like, I mean, it's very common. I mean, it's a kind of go-to method. I can say usually we wanted like a standard sharding, then we can say, hey, let's go ahead with the hash sharding mechanism, and we can like just like divide our table and we can distribute our particular data accordingly. So if you have a highest query performance when querying large table for joins and aggregations, then probably this is one of the go-to method which you can prefer, and you can say that, hey, let's go ahead and plan our particular data distributions or table distributions with the hash mechanism. Now behind the scene, what this particular hash function gonna do is that, so hash function utilize the overall value of the declared distribution column to assign each row, and that is something going to associate it to your particular respective compute node what you have, and accordingly your the process of that particular data will be taken care behind the scene. So that's one of the standard approach I can say, or standard mechanism what I can think through in terms of hash distribution I can consider. So that is basically actually it will give you a kind of interactive mechanism in terms of processing your particular data, right? So there are some performance consideration for selecting distribution column, such as like distinctness or data skew and the type of queries that you are planning to run on the system. Then in certain case you can go ahead with the hash mechanism, what you can think through. Now so that's particular one mechanism. The second one, I can say replicated one. Definitely, I'll talk about the default one last. The round robin one, we will talk about last one. So second one, second mechanism I can think through is the replicated one. So here you can say that replicated table. So here what you can consider that you may have uh, default data, and on top of that maybe you can think through that you may have your particular table, and this particular table probably let me have a compute nodes, right? And here we can say that each particular node will have that particular default you can say table replicated. Right, so here I can consider that in this replicated mechanism, it provides that fastest query performance for small tables. So usually if you are planning to have some particular data processing where you have let's say I just wanted to collect some demographic information of my users, where I just have uploaded my informations and I wanted to collect maybe product wise or probably some particular what do you say, the purchase order wise or something like that, some particular standard queries which you wanted to distribute and execute on top of it. So you may simply go ahead and say that, hey, I do have this particular table, let's replicate across the compute nodes and we can have some faster result as an output of it. So table that is replicated caches a full copy of that table on each compute node. So whatever the component we see over here is something going to be replicated or cached with each of my particular compute node. So definitely, I mean, these are, I'm assuming that these are my particular SQL and my particular DMS component attached to this, my each of my particular compute node. And the copy of that particular table will get cached to each node, consequently replicating my each table, which removes the need to transfer data among compute nodes before a join or aggregation execution, whatever we are planning to do. Because end of the day, in other activity, what it does, that it may go ahead and transfer the data, and after that the compute node going to execute that queries and all. So in such case, this is something, the caching will be done and it will replicate my particular table on each and every single compute node, and then they will help me to process my particular data before any like aggregations or any queries what you perform on top of it. Now the advantage is that in let's say for example, if you have some extra storage you need, or you need some additional overhead query or some data to be execute on top of it, then that will be like you can increase little bit capacity. But if you see that like, okay, you have a large amount of data, large amount of tables, which is something you wanted to go ahead and process, then probably this is not the right way to go ahead. In that case, probably you can probably distribute your particular data and you can go ahead with the hash mechanism. So that way, probably you can divide and conquer your particular queries on top of it. So as I rightly mentioned at the beginning, that if you're looking for some small table fastest queries to be executed, then in such case the replicated table or replicated mechanism works effectively in such case, right? So when you have some frequent data uh, modifications and all, and which may cause your copying of your particular data and all, so it is just advised that if you are looking for certain kind of activity, then the standard replications and all, then this is something the best way to go ahead with your particular data processing and all. uh, in this particular case, the third mechanism is something what we can, I mean, as I said that, as I asked, like which one is the default one. So we're going to have a default, what do you say, the query performance or distribution mechanism will be our round robin, right? So you can have a simple round robin distribution mechanism. In fact, I was about to write RRR. So this will be like round robin distribution. I hope, I mean, everybody's like understood what I'm trying to say. So here in round robin, basically this is like a kind of uh, you can consider that it's one of the default replication mechanism, right? So round robin is commonly used when you are using a straight table for load and very simple type of execution when you are looking at it. So in such case, it works in a circular fashion, and all the table row will be placed into each node in a sequential pattern. So it is very quick to load your data into round robin table. But the performance of the query will be better with hash distributed tables. If you're looking at some large set and all that particular stuff, then that is something what you can expect. So here what you get is that maybe in this particular consideration, I can consider that maybe I can have uh, row 1. I'm just like, instead of making table, I'll just say row 1, you have row 2. Okay, and you may have some like random row, so I'm just like adding. Now what you're looking at it, that these rows to be distributed and stored based on the round robin mechanism what we have, and we just wanted to associate or attach it to our particular what do you say, the table distribution mechanism. So in this particular case, whatever the table approach we have, we just wanted to make sure that this will be round robin and associated to my particular distribution node. So here I can consider that we may have our particular nodes. Let's assume that we may have 3 nodes. Okay, and each node, let's assume my data is going to be round robin to each of this particular nodes. So in that case, probably the row number what we have defined, the first node what we have, maybe I can say round robin point. I'm just like visualizing that what could be the if impact in my particular data and how that round robin mechanism works. So I'm just like trying to a little bit visualize that and sharing my particular data, or it will get shared behind the scene to my node. So I can say that this will probably randomly 147, maybe this will be you can say row number 2, 5 and 8 may go, and this will be like, let's say 3, 6, and 9 maybe. So this way, my each compute node what we have in terms of round robin distribution list. Uh, Here you will get, as I mentioned, that you will see that particular row will be placed in each nodes in sequential pattern, and it is basically loading data bit quicker to that particular round robin table. The only thing is that performance wise may get delay if you go ahead with the large set of data in place. But yeah, in general, this is something kind of pattern or strategy what we can think through or we can follow, and that will help you in terms of executing your particular overall structure what you are looking at it. So definitely when you have your table, when you have your particular distribution list and other, when you create your particular query on top of it, you will specify that which distribution mechanism you are looking at it. Say for example, if I'm going ahead with my SQL pool and I'm writing my query that create table with table name, schema, and whatever column and other stuff you wanted to define, you will say that with the table options, what will be my distribution mechanism? So in that distribution mechanism, you can apply that. Either you are looking at it hash mechanism, either you are looking at it round robin or replicate one, right? So these are the three elements what you can define, and overall it will be helpful to you in terms of scaling your particular attributes or scaling your particular activity behind the scene. So ultimate goal is that this will help you in terms of performing your particular activity. Now, along with this, you will also, I mean, when your table is getting created and all, you will be also improvising your overall query performance with indexing, right? So when you like index your particular table and whatever the queries what you are looking at it, so in such case, like when table is created, so by default data structure has no indexes, right? And that is called, I mean, in general, you guys know that that is called as a heap. And when we are going ahead with well-designed approach with our indexing strategy and all, that will reduce our risk of IO operations and consume some less system resources, so that we can improve our query performance. And that way, especially when we are going ahead with filtering, scanning, join, and query our particular data, then if indexing is there, then that will really helpful. So when you are going ahead with dedicated SQL pool, then you have some particular standard indexing mechanisms available. So you can call it out as in, let's say there are some uh, standard mechanism where you can consider that indexes. So here you can say cluster, clustered column store, right? You have clustered index, and last but not least, you have non-clustered one. Oops. So in this particular three elements, we can consider that if it's a sorry, if it's a clustered columnar index, then this is basically when you create your particular dedicated SQL pool, dedicated SQL pool, when you as soon as you create a clustered columnar index, when no index options are specified on a table, then this is something what you can say best way to go ahead. So clustered columnar index offers like uh, highest level of data comparison as well as the best overall query performance on your particular distributed table mechanism and all, right? So when you are planning to go ahead and have your system to be defined, so this columnar index will, I mean, you can say generally outperform cluster when you have your indexes or heap tables, and you're usually planning to go ahead with large set of tables and all. Then this is something best mechanism to plan with your data processing and all. And in addition to that, you will get data compressions, which is something allowing you to reduce your size and less memory so that you can access your data with reduced IOPS, and you can retrieve your data from the storage whatever you have. So it will also help you in terms of compression of your particular data. And it works on like more than around 1 million rows that compress and optimize by column. So this will be like one of the uh, standard mechanism, I can say, which you can go for when you have no specifications with your tables and you have large set of data. Probably this is one of the mechanism what you can think through. In terms of clustered index, here I can say this is something. It's a kind of how the table. I mean, it's a kind of mechanism. It indexes your table, and your table itself store your. You can say it will store or order by column, and it will use with that particular index. So there can be only one clustered index on a table. That's basically a standard what is followed under this particular mechanism. So these particular indexes are best when you have queries and joins which requires range of data to be scanned, preferably in some particular order, and when you have some indexes are defined. So let's say, for example, I wanted to keep a track of my data where I'm looking at some product catalog which range across this X amount to X amount, and I wanted to query some particular data and see what is the current sale or something like that. I mean, I can have some particular standard index and I wanted to see what is the best selling products out of this particular component. So, I mean, just a wild example. So kind of clustering, I can do it where you need some sort of when you need some data range to be defined and all, then this is something what you can think through, where you can apply and you can configure certain kind of activities the way it is expected. Last but not least, the non-cluster index. So in this particular activity, I mean, when you're going ahead with the non-cluster one, so this is another indexing mechanism. So here you can say that a non-cluster index can be defined on a table, or probably you can say on a view with the cluster index or on a heap. Each index row, which is something defined or configured with non-cluster index, they may have their particular non-clustered key value and a row locator. So this is basically a kind of you can say a data structure where you need separate or some particular separate table or heap, and you want to create some multiple non-cluster indexes on a table. So this is like best use in terms of column where you have some join or group by statement or where clause which returns some exact match or few rows in that particular case, because where you don't need some specific indexing, you just need that, okay, oh yeah, if this is the case, then I just wanted to return some XYZ data out of it. So where you don't need any mapping, where you don't need any specific what do you say, like standard result which is dependent on something, then this is something a standard way to go about it, and you can simplify your way to define it. So this is something what we are looking at it. We can have we can have a particular a standard approach where we can say that it will help us in terms of uh, provisioning our resources, provisioning our particular method out of the box, where we can say that which mechanism we are expecting, which particular component we are expecting, and how we want to approach our solution with the specific method. Now, if I'm going ahead with my Azure portal, let me show you. I have provisioned a couple of elements, and if I go to my portal and say create resource, so there are multiple way. Uh, Dedicated SQL pool. This is one of the straightforward way in terms of creating your dedicated SQL pool. Other ways, as I mentioned earlier, that in my previous session I have explained regarding that what is the next way or what is the easiest way to create your SQL pool, either serverless or Apache or probably the dedicated one from the portal under AS Studio, Synapse Studio. That is something one of the way to create it. And this is where we can say you can simply go ahead and plan your particular structure. Then maybe I'm just giving random name ASA DW pool. You can provide the server. Here is the performance level. So this is something what we can plan it out, right? Uh, Always preferably to go ahead with Gen 2 because here you will get the generation 2 API and the latest and greatest updated mechanism, which is something available with it. And of course, I mean, you know that as soon as the cloud grows, you will see some of the other new APIs and features are getting ingested. So always go ahead with the latest offering. So here I can say the performance and storage capability of my ADL, Azure Data Lake Storage, is something applicable with generation 2. So minimum will be your 100C and maximum you can go to, oh sorry, I mentioned 3, it's 30K. So it's your data warehouse unit, and this is the maximum particular unit what you can consume when you are planning to run your particular query. You have minimum 1 and maximum 60 nodes, compute nodes will be available, and these particular warehouse unit will get distributed accordingly, and your what do you say, based on your design method, based on your particular data, it will query and perform the activities the way it is expected. Now, if you're planning to do this hands-on, please go ahead with 100C because right now, I mean, you are just like into testing purpose, so no need to pay a high cost. And even, I mean, if you are like in free trial or in anything, then definitely you will not get that big scale of unit initially because it is something applicable with enterprise grade subscription or pay as you go and other stuff, right? So maybe that way we can minimize the cost. So if I say this is my default configuration, of course networking is also applicable. So I mean right now I'm not configuring this, but yeah, definitely in my additional settings, probably when you are planning to go ahead with any configuration, if you do not have your organizational data, you can simply go ahead with your sample data, which will create an associate to your particular data warehouse unit, and then you can simply process with the informations or query strings whatever you expect. So here you have that particular structure, and as soon as you provision, so I have my, I'll just click on OK. So here I have my workspace in place, and what I have done, just for information, that I have provisioned one virtual machine. Okay, and this VM I have provisioned. Right now we are inside the VM. I have just RDP into my instance, and we are just connected with this particular instance. And inside that particular VM, I have installed my the SQL Management Studio SSMS, and with that SSMS, I am running all these particular activity the way we wanted to execute, right? So there are some particular standard queries. You can define your particular replication mechanism or sorry, not replication mechanism, distribution mechanism. Whether you are looking at it replicated one, whether you are looking at it probably the default one, which is round robin, or are you planning to go ahead with hash one? So accordingly, you will get your particular distribution mechanism in place. So ultimately, I mean, uh, when your configurations are in place, so and even like for learning point of view, if you guys like thinking about like how can I set up and what kind of options I can go ahead, if you have subscription in place, free trial or any other, best way to go ahead is provision one virtual machine. I have provisioned like VM with B2 standard B2 series, so that will not cost you much. And inside that VM I have installed SSMS, the free version of it, and inside that I have configured my warehouse instance and all. So as soon as you go ahead with your management studio and all, definitely you need your particular server destinations, which server is going to allow you to connect and all that stuff. So here is my server, and inside that server, from the virtual machine itself, I'm configuring my firewall rule and all. So I wanted to prefer that whenever my instance is going to connect with my studio is something defined with my services and all, right? So you may say that add your client IP and allow Azure services to like access this server. So at least you can keep it yes. So next time onwards, whenever you are trying to connect and access this resource, you may work effectively. So in general, this is basically the structure, or maybe you can say the resources which I have created so far. And with this particular services, we will we can execute our particular queries. We can run our particular structure on top of it, and it will helpful to you in terms of executing query. Now I have just triggered one query. So I mean, though I have very low, what do you say? I purposefully I created this particular with 100 DW unit, and I'm trying to run like very high configuration based queries, so which is taking some time for me. So just to get you idea that, hey, if you have right set of data, you have right set of configuration, but if you minimize the configurations, if you minimize the warehouse unit with some specific configuration, then definitely that will degrade your performance. That will create some latency in terms of resulting your particular queries, and then you will not be able to see that particular data on time the way you are expecting. So I have created some table, and data is in place with some sample execution, and I'm trying to like run query with around millions of rows, and it is trying to aggregate data and give me some particular result out of it. So in general, uh, I mean, this is basically the query is getting processed. So uh, one of the core thing, it's not just only having your right distribution method in place, the way we discussed, either your round robin, or you can say a replicated table, or you can say the hash one. So it's not just only the distribution mechanism, but you also need to take care of three elements of it. First thing is your data loading, from where your data is ingested. Nowadays the pipeline creation is like very common, and it becomes more popular. So you may have your particular pipeline in place, you may have your particular queries to be written in place, and at the end you define your particular concurrency along with that. So it is always advisable that combination of all three will improvise uh, uh, your distribution, your indexing. Will be adding more weightage towards your configurations, and at the end you will get some well defined approach to play around with the services the way you are expecting, right? Now just for your reference, I would like to share, or that URL will be also shared in your chat. So here is your particular exercise where I can suggest all of you to take a look at it. Here is the documentation where at least you will get familiar in terms of utilizing your indexing mechanism with your SQL pool, and you will run some sort of mechanism, right? So here, as I mentioned, that when you create your table and all, and when you are planning to run your queries, you will be defining that which mechanism you are planning to go ahead. So default one is your round robin, but you specify that I wanted my customer ID, distribution key, and then I wanted my index to be done, and then I wanted to execute my overall structure on top of it. So that way at least you can play around with your particular data, query those particular informations, and you will see that how the overall aggregation works throughout your particular activity. So there are some steps given. Only the one thing assumption is that when you are planning to work with this, you may have your ASA, your Azure Synapse Studio in place, and behind that particular Synapse Studio, or maybe the pool what you are creating, you can simply perform this particular activity in a step-by-step way. So you will get some step-by-step activity. There are some structures given, samples given, and at least you can validate that whatever the mechanism you are going ahead with it, how the data is aggregated in your particular table, and while using any one of the distribution method, how you gonna improvise the overall performance and query throughout your particular life cycle. So that's what the overall activity what you can go ahead and you can plan with the solution what you have, right? So yeah, I think high level, the explanation on the design mechanism, distributed design methods, what kind of method what we have provided by the Azure Synapse Analytics. And here is the link with you. It is there in your chat as well. You guys can go ahead and visit this particular learning module as well for your reference, which you guys can utilize, and later you can work on that particular activity as well. So that will really helpful to you. Yeah. So that's all from my end. Any queries or questions from all of you? Please feel free to let me know, and I'll help you out with answering those questions if in case. And if no questions, then thank you so much for attending session. And there are many follow-up sessions are coming up, so stay tuned, and we will be having further upcoming sessions to be connected, and we can continue like having such kind of knowledge sharing with each other.
We'll just wait for another 1 to 2 minutes if there is any
Sure,
questions.
absolutely.
In the meantime, I
Yeah,
have already sorry, anybody for asking question? Yes, please go ahead.
yeah, I'm Sandeep Goyal. No in-depth question, but yeah, I just want to know like if I have to like read more about it. I mean, you have given two URLs, but like
Mhm.
if I have to know like what is the exact scenarios and in which I mean like trying to say that
Use case, you wanted some use case or some case
some
study?
yeah some use cases and like when what is the exact scenario that we should absolutely go for this as a solution
Mhm.
in terms of what we have as a product and what we maintain as a product.
Okay. Sure, Sandeep. So I think maybe I can do one thing. If you can connect with me, and I can help you out with some reference material as well, as this is like 1 hour session, so it will be
Yeah,
very crucial to like collect a lot of things and share. But
yeah,
yeah, definitely you can reach out to me, and I can definitely help you out with those informations. Absolutely.
yeah. Okay, thank you.
Yeah. Yeah.
Yeah,
Sandeep, just to add, Jigar's social handle, all links are there in the meetup page, so you can take,
Correct.
yeah, from there.
okay, okay. And this link that you have provided is the same which we were seeing on the video when you were demonstrating like the
Correct.
uh,
Correct.
okay.
Right now, the link which you have got in chat, that is something which I was just showing in my demo. That was the link. And the further informations, as Rasmita rightly mentioned, that you can connect with me over the social media, and definitely I can help you out with further information in that case.
Sure.
Yeah. Okay.
Yeah. Yeah.
Do we
So,
have any more questions?
Okay. I think
Okay,
then
yeah.
thank you so much, everyone.
Thank
yeah,
you
thank
so
you.
much, Jigar. Thank you.
Yep. Thank you. Let's connect back in any in upcoming sessions then.
Yeah, sure. Thank you so much.
Thank
Bye.
you, guys. Bye bye.